So we finish the warm-up, highlight the word linear, and underline. There's a word in linear that I think is really important. What word is in linear? Line. Okay? So guess what all linear functions need to be? A line. They need to be a line. Okay? So that's how we're starting. This entire lesson is identifying linear functions and then applying at the very end. Okay? So we're going to look at a bunch of different graphs. If the graph is not a line, it's nonlinear. If it is a line, then it's linear. Okay? So let's check out the first few graphs. In A, does that look like a line to you? What does it look like? It's a curve, right? So would we call this linear or nonlinear, peeps? This one's definitely nonlinear. Make sure that you label it a nonlinear function. Is this still a function? How do you know? Who said yes? David. Good. Doesn't cross over what? Good. There's a test. Does anyone remember the name of the test? Gabriel?
Vertical line test.
Excellent. It passes the vertical line test, okay? So, okay, moving on. Guys, take a look at B. Do you think that is linear or nonlinear? I heard a lot of linears. Why was this linear? Is it a straight line? Yeah, it's linear, okay? It's a linear what? Function. How do we know that this is already a function? None of what kind of lines? I need a letter with a V. Vertical lines. None of the vertical lines will intersect it twice. Do we see that? Okay, so that means it's a function. For it to be linear, though, it needs to be a straight line. Do we see that? Are we Gucci? Okay. C. Uh-oh. Linear. Why? It's a straight line. Is it a function? Yup. Boom, bada bing. Are we starting to see it? Love that for us. Okay, go to D. Tried to trick you. Is D a linear function?
No.
Good. Why is it not? It's not a straight line. What happens in the middle? Changes direction. It's like jagged. Do you see that? So this one's nonlinear. Is it a function though?
Yes.
Why? Good. Take your vertical pencil, draw it all the way along. Is it going to hit twice anywhere? No. So it's still a function. Are we Gucci with this? AJ, what's up?
If it wasn't a function, would you write non-linear,
It wouldn't be linear or nonlinear. So if it's not a function, you can't label it either one. Okay? That's a very good question. If it's not a function, it can't be linear or nonlinear. It's just not a function. Okay? So instead of nonlinear, you would just write not a function. Make sense? So if like you saw a graph like this, obviously this isn't a function, right? Don't call this nonlinear. You would just say not a function. Okay? You got it?
There's another fly in here.
I know. They keep coming back. David, what's up? Transitions. Okay. Please copy down both of those steps where it says check X's rate of change and check Y's rate of change. It'll load in a second. Give it a second, guys. Check X's rate of change. Check Y's rate of change. Oh, it loaded, guys. So it's up there. Do you guys see that? Okay, those are our two steps. So we have to check both our inputs and our... Do you have to check both? Yep. Yes. Can you only check one and get away with it? No. Nope. Now, what it means to be a rate of change. Guys, listen carefully. That is only addition or subtraction. A rate of change is only addition or subtraction. So if you notice that there's a pattern in your table, but it's multiplication, is it a rate of change? No. It must be added or subtracted by the same value. Are we Gucci? Okay, so take a look at letter A. Let's go through the X's. Does anyone notice what's being added or subtracted to all of the X values as we move from left to right? Gabriel?
+3.
Bingo. It's +3, +3, +3. Once we've done step number one, which was check the X's rate of change, ask yourself, was the rate of change consistent? Was it going up by the same value? Put a check mark, okay? So as long as it's consistent, we're like, okay, we're Gucci. We're Gucci so far with the x's. But I told you have to check how many? Both. So what else do we need to check? The y's. Does anyone notice what the y's are increasing or decreasing by? Michael? -6. Very good. Is it consistent?
Yes.
If you subtract 6 from 24, what do you get? So are we Gucci? Okay. If they both are consistent rates of change, guess what we can call this guy? A linear function. Okay. Now, how do we know that it was a function before we checked whether it was linear? David? All of our x's are different. Do you guys see that? So we can label it a function. And it's linear because the rate of change was consistent. It was +3 the whole way for the x's. It was -6 the whole way for the y's. Oh.
Wait,
Yeah, AJ?
it's not consistent on me?
Very good. But it could still be a function. The function junction. Okay, moving on to B. Check it out. What do we check first? What do we check first?
X.
Thank you. Are my x's consistent? What's the pattern? +2. Is it consistent? Yeah, awesome. It's +2 the whole way around. What are the y's? It's not consistent, but let's label it. How did we get from 2 to 9? They added 7. How did we get from 9 to 20? +11. So right now, I already know it's not consistent. Do you guys see that? But let's finish it. How did they get from 20 to 35? +15. If they're all different, can we say that the y's were consistent? Can we say that the y's were consistent? Put an X. As long as one of them fails, it is a nonlinear function. Very good. Why is it still a function though? AJ? None of the what are the same? The inputs. Do you see how all the inputs are different? So it's still a function, but it's nonlinear. How are we feeling about this so far?
Excellent.
Would you guys like to try the next two on your own?
Yes.
Go for it. They're on the next page. Try C and D by yourself. Don't talk about it. Don't compare it. Very good. What was the change in our x's? AJ? You were adding 1 each time. Very good. Did we put +1, +1, +1? I'm checking for that. Did we put a check mark? Excellent. Did we check our y's? What was the pattern in the y's, Natalie? +2, +2, +2. Was it consistent? Bingo. Did we put a check mark? Did we write that it was a linear function?
Yes.
Let's go. D. McCarvin? You would be correct. Why is it nonlinear? The second one, even though there's still a pattern, it's being divided by 2. If you write minus, not 7, -8, -4, -2, this is still nonlinear because it's not consistent. We Gucci? Questions? Okay, now comes the fun part. Okay, so the last way to identify whether something is linear. So if a graph, if it's linear, it's what kind of graph? A straight line, right? If it was a table, what do we notice about the tables? What are we looking for? Not just a pattern, rate of change, right? It's a constant rate of change. You're adding by the same amount. If it's an equation, it must match the equation y equals mx plus b. Highlight that. Y equals mx plus b. We have to be able to rewrite our equation in this form if it's linear. If it's nonlinear, then we may not be able to write it in this form. Understood? Okay. Now, please underline what I underlined. There are no square roots. X cannot be an exponent or have an exponent other than 1, and it can't be in a denominator. Could x be in the numerator? Yes, but where can't it be? In the denominator, okay? So please underline that and highlight the equation y equals mx plus b. We're going to start with an easy one. So jump right to the middle. Let's do E together. On top of all of these problems, I want you guys writing, at least in the beginning, y equals mx plus b, because we're trying to get it to match this. What would you guys try to do to this equation to try to match y equals mx plus b? Yeah, Matthew? Good. Distribute what?
6
Perfect.
x and -1.
When you distribute, what would you get?
6x and -6.
Perfect. Did you guys hear Matthew? He said distribute the 6, and you're going to get y equals 6x minus 6. Are there any questions on that? Now watch. Is this in the form mx plus b? Remember, m's going to be a number, and b is going to be a number. If you think it's an mx plus b, what's the value of my m? McCarvin? It's 6. Does anyone think they know the value of my b? AJ? -6. Now, if you don't see that, I'm going to show you by highlighting. I want you to highlight the m in blue and highlight the 6 in blue. Do you see how the m is in the same spot as the 6 in our equation? I need either a nod of approval or someone to say yes. Do we see that? Yes. Okay. Do you see where the b is? The 6 is where the b is, but what's different? The negative. So our b is actually a -6. Do you guys see that? Highlight that one in green, please. So the plus b was a -6, so b is -6. If you can match it up like we did, what do we call this type of equation? A linear function. Mia?
Would it still be the same thing because it's a -6 and you're adding?
Yes. Mm-hmm. It's still -6 though. But your b cannot be +6. It has to be negative. Got that? B has to be a -6 because it's -6 here. Do you agree that this is the same if we threw a plus sign in here as 6x plus -6? No, the m does not have to be positive. How you recognize the m? Did it disconnect again?
Yeah.
Okay, hold on. Guys, go up to B. Go up to B. Y equals, that is the square root symbol or a radical. Can we have that if it's a linear function? No. This one's non-linear. Okay? And in the beginning, I want you writing y equals mx plus b above it. Is there any way we could get this guy to match this one above it? No, there's nothing we could do. Okay? What's up, Alec? The final answer for E was that it was linear, okay? M could be equal to 6 and B could be equal to -6. Okay, this one's a little tricky. I want you guys to scoot over to A. Matthew, did you have a question?
Yeah. How do you know when it's linear and non-linear for just doing the equation?
When it's in the equation. So anytime you see, you should highlight this symbol. If you ever see that symbol in there, it's going to be a nonlinear function. Okay? You can't have the square root of something because that's technically an exponent and you shouldn't have any exponents for your linear functions. What's up, Karen? So E, we were able to match it to this. We could write it as y equals mx plus b. I told you your m was 6 and your b was -6. In here, you can't because there's that square root symbol. It's never going to match y equals mx plus b. Yeah, Karen?
So, now I'm saying, how can it's a linear, like, why does that have function, but not the
Oh, it is a function. Sorry. You're saying why doesn't this one have function? It should be nonlinear function. Sorry. Thank you, Karen. Good question. Did you guys hear that question? They should both still be functions, but one's linear, one's nonlinear. We're just going to label them all functions for now, okay? Good question. How do we normally check if something's a function? We check the inputs or we use what?
The variables
the vertical line test, okay? We don't really have a test for it with equations just yet. We will learn that later, okay? But with equations, we're going to assume that all of these are functions, okay? We're just determining whether they're linear or nonlinear. Those are great questions. But Carvin, what's up?
Is it possible to like graph equation or function?
Yep, that's the next part. Yep. Okay, so in letter A, it says, does the equation represent a linear or a nonlinear function? We need this guy to match y equals mx plus b. Do you guys agree?
Yes.
Now, let's think about this. That 3.8, it's either my m or my b. What do you think it is?
It's your M.
You think it's my m? M always has what next to it? X. It's your b. So my b is 3.8. What don't you see here though? The x. So my m is actually what? Does anyone think they know the value of m? Gabriel? No. Because if m was 1, do you agree 1x, would there still be an x here? If x is gone, m is 0. So we're going to write y equals 0x plus 3.8. Do you guys see that now? So my m is 0 and my b is 3.8.
It's not popping up.
It'll pop up in a second. Just wait for it. You see how we're matching up what the m should be, what the b should be? If your x is never there, what's the m value? 0. Let's look at C. Wait. What do we label this? Linear or nonlinear?
Linear.
This one's linear. Because we could match it up, right? And it's going to be a linear function. M was 0, B was 3.8, and it's linear. Let's take a look at C. What do you guys think? Is this one linear or nonlinear? Natalie? Good. Are you allowed to have exponents, guys? No. So this one's nonlinear. You know for a fact this one will never match up with y equals mx plus b. Don't just put no. Put non-linear function. Remember, you can't have exponents here, okay? For it to be a linear function, it needs to have no exponents. Could you have a fraction? Absolutely, okay? Take a look at D. Y equals 2 over x. I told you x can never appear in the... Is it in the denominator here? So is this linear or nonlinear? Nonlinear function. You guys are on the ball today. I love it. Let's keep it going. Don't get cocky, AJ. You guys are on the money today. Could x be in the numerator?
Yes.
Could x be in the numerator? Yeah, take a look at, well, first let's do f. Is f linear or nonlinear?
Non-linear.
This one's nonlinear. Why? There's an exponent. What's the exponent? The 2. Okay, circle it. Sometimes it helps if you circle what's causing it to be linear or nonlinear. Make sure you have the word function. G. So let's write y equals mx plus b. Do you guys think this one has potential to be a linear function? Yes. Now, some of you guys, this is confusing. This is a 9, not the letter A. So if you want to extend it to make it look more like a 9, please do so. But that is a 9, not the letter A. What is my m in this linear equation?
0.
David?
1.
It's 1. Why is it 1? The x is there. If x wasn't there, what would m be?
0.
But since we see it, what's technically in front of this x, guys? A 1. So m is 1. What is b? 9. If we can match both of them, we call it a linear function. So if x ever isn't there, what's my m value? 0. And if x is there with nothing in front of it, what's technically there? A 1, because 1 times x is still x. What's up, Gabriel?
Why is D nonlinear?
Why is D nonlinear? Because you can't have x in the denominator. This is technically y equals 2 over x, right? Shouldn't be down here, okay? It can be in the numerator, it can't be in the denominator. Good question. Other questions? Okay, go to H. Y equals 3x over 5. What are we thinking? You think it's linear? You would be correct. What's my m value here? It's not just 3. It's not 3x.
Is it 4?
It's 3 over 5.
Oh.
Do you guys agree that we're taking x, we're multiplying it by 3, and we're dividing it by 5? Isn't that the same as saying y equals 3 over 5 times x? We haven't seen this before? Okay, then write it down. These are the same, okay? 3x over 5 can be rewritten as the fraction 3 over 5 times x. Because x is technically x over what? 1, right? If you were to multiply these fractions across, right, you would get 3 times x over 5 times 1, which is just 3x over 5. So these are essentially saying the same thing, okay? So my m value is what? 3 over 5, no x. M should never include x. What's my b value?
0.
It's not 1.
0.
It's 0. If you can't see it, what is it?
0.
It's 0, okay? B equals 0. Karen?
Why do you use the X for M?
You don't use the x for m because remember, our formula is y equals mx plus b. Do you guys agree? Do you see how m is next to x but not part of x? So you have to leave the x separate. If you put x as part of m, you're going to get x squared, and that's wrong, okay? Because you're taking an x and multiplying it by another x. M should be just a number. So just the 3 over 5, which is a fraction, okay? Good question. Any other questions on this one? Okay. The last one, I. Oh, wait. Did we label this one? Is this linear or non-linear? Linear. Function. I. Are we going to be able to get this guy to match y equals mx plus b? Why not? The exponent. Circle it. Right? This is a nonlinear function. Are we starting to see it?
Yes, sir.
Please, guys, look at this where it says discrete domain and continuous. Okay? A discrete domain is when your points are being listed out, right? So you're going to have individual points. Your domain is going to be like a list of numbers. So if we were to see these points on our graph, right, we would say our domain is just the list of points, right? It's 1, 2, 3, 4, and 5. Do you guys agree with that? And then we would list it as an inequality if it was there was a line connecting them. Do you guys remember that from domain and range?
Yes.
So this 1, 2, 3, 4, and 5, this is what we call a discrete domain. When you're listing out the points in your domain.
So you're just doing.
What's that?
That's the one you do.
We've been doing some of these, and we've also done some of these where we write in an inequality. Do you guys remember that? So what values in my domain down in the bottom, what are my x values between? 1 and 5, right? And we always use 2 less than or equal to symbols, correct? since they're closed dots, and we put X in the middle. This is an example of what kind of domain. Is this discrete or continuous? This one's continuous. Do you guys see the difference? Anytime you're using an inequality, so you're including the numbers between the points, that's always going to be continuous. It's a continuous line. It includes all of these numbers. When it's discrete, it's individual points, okay? And let me show you the difference. So the number 4.5, do you agree that it would lie somewhere between 4 and 5?
Yes.
Is that part of this domain up top, the discrete domain? No, because it's not listed as a number. Do you guys see that? Now, look down. Would 4.5 be a part of this domain? Yes, because the line is filled. Do you guys see the difference? So all the numbers between 5 and 1 are included. All of the numbers between 5 and 1, unless they're a whole number, are not included. Okay? Discrete versus continuous. Okay, you're going to skip the next slide, and you're going to go all the way to the last one. We're just going to do example 6, and we're going to call it for today. Okay? We'll finish part 2 tomorrow. Is the domain of each function discrete or continuous? This will take us 2 seconds. Look at the first one, A. Discrete or continuous? Why is it discrete?
Because it's individual points.
Good, it's individual points. The second one, B. Discrete or continuous? Continuous, because why? Because what?
It's full.
What do you mean by that?
It's like a full line.
It's a full line, okay? If they connect the dots, if they draw a line, it's continuous. C, discrete. And the last one, D, continuous. Continous. Yeah,
Who came up with these names?
me. I did not come up with these names. I don't know. Google it. Google it.